I'm presenting EmbER, a system for transfer of interoceptive sensations to improve social perception. I'm Caitlin Morris from the MIT Media Lab, and my co-authors include Valdemar Danru and Patty Maas, also from the MIT Media Lab. The experience of social connection is essential to well-being. A sense of social connectedness depends on interpreting communication cues from conversation partners. In face-to-face interactions, we typically have access to a wide range of nonverbal cues from various channels, including environmental elements like haptics and olfactics, physical positioning cues like kinesics and proxemics, and many others. In remote interactions, even in rich media environments like AR and VR, these channels are largely removed or reduced, leading to decreased feelings of social connection. Precise replication of the body in virtual environments suffers from challenges such as uncanny valley effects, often creating further emotional dissonance. Rather than restoring existing communication channels, we explore whether adding novel communication channels can increase a sense of social connectedness. In particular, we evaluate the impact of transferring interoceptive sensations from inside the body, such as breath and heartbeat, to another person through haptic and audio feedback. EmbER, or Embodied Experience Remotely, is designed as a multi-channel system fusing a video channel of a person speaking with augmented channels of heart rate or breathing rate, reflecting that person's physiological state in real time. In our experiment methodology, scripted data designed to simulate a narrator's physiological arousal state is fed to the control software to drive outputs. In the haptic mode, a microcontroller is driven by the control software to vary haptic pulse speed conveyed through a custom wearable wristband with a vibrating motor. In the audio mode, an added layer of Brownian noise is volume enveloped to create a rhythmic breathing pattern overlaid on the voice audio from the speaker. Both methods were calibrated to sit just below the level of conscious perception, not requiring or demanding attentive thought. In the calibration phase, vibration and auditory noise were played through the wristband and headphones, respectively, to determine a feedback level which would be just below the threshold of perception for each participant. Participants were told that they would experience sounds or vibrations similar to a breath or heartbeat, but were not told that this specifically belonged to the narrator. The video sequence used for assessment in our study consisted of 3 pairs of videos, each pair followed by a short survey. In each pair, a short video of a nature scene played first to act as an emotional neutralizer and allow the capture of an affective baseline state. Following the nature video, the participant watched a 5-minute video of a filmed narrator describing an emotional experience. After all the video cycles were complete for each condition, the participant engaged in a phenomenological interview to understand how the participants experienced the narrators and how that experience was influenced by the EmbER system. To evaluate the impact of EmbER on social perception, we deployed a mixed methods approach which incorporated self-report measures, physiological data capture, and the post-study interviews. In our assessment of participants' post-video survey results, we saw the most notable results on the item relating to feelings of connectedness. We measured significant effects of the breath condition on participants' feeling of connectedness toward the narrator, measured on a Likert scale. We also saw an increase in the number of physiological arousal events or significant changes in heart rate in a short time interval as compared to the control video condition. We organized the phenomenological interviews into a series of themes which arose in discussion with the participants. Participants noted that their level of conscious perception of the feedback device was related to their feeling of connectedness toward the narrator. Many participants reported hearing no augmented feedback in the audio channel, despite the increased effectiveness of this modality on reported connectedness, indicating that the effect was primarily unconscious. Similarly, many participants reported being consciously aware of the haptic feedback and that their awareness created a sense of disconnect as they did not fully interpret the sensation to be their own. This was likely related to the lack of significant improvement in the haptic condition, which can be addressed in future work. We also observed participants engaged in reflective processes to determine the self-other relationship to the device. most participants intuitively understood that the sensory information belonged to the narrator, despite not being specifically told whether the sensation was meant to mimic the narrator or their own body. We begin to see trends towards increased physiological synchrony between the participants and the simulated narrator data, especially in participants who reported a stronger feeling of connection via survey. Here, in a cluster of the 3 participants who reported the highest sense of connection in their surveys, we begin to see patterns of synchrony between the simulated heart rate in orange from the narrator and the participant's real heart rate in blue. We compare this to participants who did not report a strong sense of connection, where few markers of synchrony are evident. We look forward to investigating this trend in future work. In this work, we presented EmbER, a method for augmenting virtual interactions with a remote partner's interoceptive sensations to improve emotional connection. We showed that the sensation of a narrator's breath, added as an audio channel, caused participants watching the narrator to feel an increased sense of connectedness as compared to those without the sensory augmentation channel. In future work, we would like to extend this platform to real-time interactions between remote partners. We also hope to further develop the sensory feedback modalities, including the haptic feedback modality, for a more intuitive sensory experience. We hope to highlight the potential for augmenting digital interactions with shared interoceptive data and explore possibilities to improve one's sense of social connection, which we find a critical component of well-being. Thank you.